Hello there, welcome back. This is 8-5 and we're talking review of trig. This video is going to specifically deal more with your knowledge of the unit circle and the conversion between degrees and radians. So I recommend having a unit circle on hand or kind of going back and watching another video on the unit circle to brush up. I teach my students in Accelerated Math 3 something known as the hand trick, where you can use your left hand, you can put down that angle, and then you can see the coordinates for those locations. I should have videos linked to those below on my website, so you can watch those if you want. But without further ado, let's go ahead and review some more trig. All right, example 4 is dealing with unit conversion. So remember that to convert from radians to degrees, 2 pi radians, one trip around the unit circle, that is 360 degrees. So the conversion rate is pi for every 180 degrees. Okay, so if we want to go ahead and convert these angles into degrees, we can go ahead and we can take pi over 2, and we can multiply by 180 over pi. So, but hopefully you recognize that pi over 2, that is 90 degrees, right? And then same with these other angles, pi fourths. Again, I can do the same thing. I can multiply by 180 over pi, or you can just know that, hey, pi over 4, that is 45 degrees. Okay, pi over 3, same thing. I can go ahead and multiply by 180 over pi, right? 180 degrees, because I want degrees, right? I want degrees on top, and I want to divide by the radians, so I cancel the radians. Okay, and this will give you 60 degrees. And then pi 6, hopefully that's the other angle that you remember in the unit circle, that is 30 degrees. All right, example 5, convert from radians to degrees or degrees to radians without a calculator. Okay, so 5 pi divided by 4. So if I want to go from radians to degrees, it's the other way around. So I take 5 pi over 4, and I want, again, degrees, right? So 180 divided by pi, so I can go ahead and do that. And you get 225. 225. Another way, too, is you can say, hey, that's 5 times 45, right? So that would give me 225. Okay? All right, 270 degrees. Whew. Here's where you go ahead and you kind of do the reverse. So if I have 270 degrees and I want to go to radians, I'll put pi on top and I'll divide by 180. Okay, and this is 3 pi over 2. Hopefully that's one that you remember. Another way to look at this is 3 times 90 degrees. And don't we know that 90 degrees is pi over 2? Okay, so that would give us 3 pi over 2. All right, negative 120 degrees. Remember that is just going clockwise, okay? So I can go ahead and know that this is 2 times 60 degrees, right? And that is pi thirds. So this is negative 2 pi thirds. But again, you can go ahead, multiply by pi on top, 180 on bottom, and you'll get negative 2 pi over thirds. Okay, you need to know how to convert. That's foundational knowledge, right? All right. Next, draw the angles in standard position and make reference triangles. So this is kind of what we did in the previous video, but with degrees, but now we have radians instead. So tangent of 5 pi over 6. Okay, 5 pi over 6, whoop, that's right here, right? And there's my triangle, and that makes a 30-degree angle, right? This is 30 degrees, or pi 6 in here. So remember with our special triangles, 30, 60, 90, that this is going to be a 1 root 3, 2 triangle. Okay, so side across is 1. The largest side from my right angle is 2, and then this side is negative root 3, right? It's going to the left. That's in quadrant 2, so your x values there are negative. Okay, so we want tangent. Well, I know that tangent is opposite over adjacent, so that is negative 1 over root 3. Easy enough. Cosine of 3 pi over 4. So, and it's negative, so I'm going the negative direction, which is this direction. okay? And that makes a 45-degree angle, or a pi-4th angle here. So 45, 90, okay? And remember, 45, 45, 90 is 1 root 2. Okay, so this side is 1, this side is 1. They're both negative, and this is a root 2. Okay, so cosine is adjacent over hypotenuse. So we have -1 over root 2. Okay, and if you want, we generally know that cosine and sine of pi-4th angle is going to be root 2 over 2. And again, this one is negative. You can rationalize it if you want. Next one, cosecant of 5 pi over 3. Okay, 5 pi over 3, that is about pi-thirds short of 2 pi. Okay, so I have a 60. That's terrible. I'm going to do this. There's that angle. Okay, so this is a 60-degree angle. And again, 60 is 1 root 3, 2. So since this is 60, this side is going to be root 3, and it'll be negative. Sides across from the 30, so this would be 1, and this side will be 2. Okay, so cosecant. Cosecant, I mean, I have trouble remembering which is which, so I use the relationship with sine and cosine. So this is 1 over, this has a co, so it's the sine function. All of them have a co paired with them, right? Sine, cosecant. Cosine, secant. Tangent, cotangent, right? They have a co-partner. Ha! You get that joke? Okay. So this is 5 pi over 3. It's the reciprocal of 5 pi over 3. Sine of 5 pi over 3. So sine is going to be opposite over hypotenuse. Okay, so this would be -2 root 3. And there you have it. All right. Okay, so next we're going to go ahead and talk about the unit circle. And remember that the unit circle is a circle made with a radius of 1. So from the center out to my radius here, this distance is 1. So if that was a coordinate location, it would be, right here would be 1, 0. And if I went up, this would be 0, 1. And if I went to the left, here, to the left, it would be -1, 0. And down would be 0, -1, right? And then we have coordinate locations all the way in between, which you can remember with your the hand trick or just sheer memorization. Okay, so we're going to get questions about these key points, and we need to remember a couple of things. We need to remember that sine of theta is y. Okay, so this is a sine value. This is a sine value. This is a sine value, and then that our x values are cosine. So remember that. And then also that tangent of theta, well, tangent of theta, this is one of the things that you need to remember, is sine over cosine. So then wouldn't it make sense that in this case, isn't it y over x? It sure does. Okay, so that's what we're going to do in this area right here. Now they do start off with it's not really tricky. This is foundational. What is sine of pi 6? So we want to go, if you have a unit circle on hand, or if you want to construct one, or if you want to remember, or if you want to look at your hand, right, you can use that trick. Okay, so we'll look at this unit circle that I have here, and we want the sine of pi 6. Okay, so that's the y value at pi over 6. And this isn't math notation, so I wouldn't write this down, but I'm just showing you, right? And that is, here's pi 6, here's the y value, so our answer is 1/2. Okay, all right, and if you use, again, the hand trick, that works wonders. All right, the rest are pretty straightforward. What is sine of 0? Well, here's my angle 0, and that's the y value, so my answer is 0. What's cosine of 0? Well, that's the x value here, so that is 1. Okay, what's the y value at pi over 2? 1. What's the cosine value at pi over 2? 0. Sine of pi, hey, that's the y value. I almost tricked myself. 0. What is tangent of pi? Ooh, tangent. Tangent is sine over cosine, so 0 over -1, which is 0. They're either 0 or undefined at your quadrantals. Okay, sine of 3 pi over 2, that's the y value, -1. Cosine at 3 pi over 2, 0. Cosine of negative pi, oh, negative. They're being negative. They're trying to get us to go the wrong direction. But it doesn't matter. It's the same answer, right? Because if I go this direction, it's still pi. Okay, cosine, that's the x value, -1. And tangent of negative pi over 2, that is sine over cosine. Uh-oh, we're dividing by 0. Answer is undefined. Okay, so that's how those work. These are pretty straightforward because we're using quadrantals, but they'll make it more difficult by using the angles in between, okay? All right, so we need to memorize the unit circle. We also need to memorize some trig identities, just basic ones. That tangent of theta is sine over cosine, that's foundational. And then also too, the reciprocal identities here, right? That cotangent is the reciprocal of tangent, so cosine over sine. Cosecant, reciprocal of sine, and secant is the reciprocal of cosine. Whew! This is lots of stuff you should memorize. Flashcards, again, and then maybe even make a notes page in your TI Inspire. It might be able to help you out. Okay, last page. Next, example 10, and kind of the next ones that we're getting into, we need to think about the unit circle, and I'll go back over here to the unit circle, and I want you to think about like what's positive in each of these quadrants. And we have a little acronym in math to help us remember this. We have all students take calculus, right? And it's just saying that everything is positive in this quadrant, that sine is positive in this quadrant. Tangent is the only thing that's positive in this quadrant, right? Because cosine and sine are negative, and that in quadrant 4, cosine is the only thing that is positive. So all students take calculus can help you out with these next few problems. So here they say if sine of theta is 3/5, find the possible values. So what I'm going to do is I'm going to draw a little xy axis, and they say sine is 3/5. So I'll make a triangle here. Okay, sine is 3/5, opposite over hypotenuse. Now notice this could also apply in this quadrant as well. Sine is, not there, Schwarberg, 3/5, okay, because it's still positive, right? So sine is positive in quadrants 1 and then quadrants 2, okay, and we get that here, right? Sine's positive in quadrant 1 and in quadrant 2. Okay, so they want to know what is cosecant of theta. Okay, cosecant of theta. Well, remember that this is 1 over sine theta. So it's just going to be the reciprocal. Okay, what is cosine of theta? Well, that's adjacent over hypotenuse. Now notice I'm missing a sign. Hopefully you remember this is a special triangle, that this is the 3, 4, 5 triangle. So then cosine is going to be plus or minus 4/5. Tangent of theta, okay. Tangent of theta, opposite over adjacent. So if these are my angles, opposite, okay, that's 3 over adjacent, which is 4, and it could be either one, right? Okay, so there you go. All right. Next, we're going to go ahead and solve trigonometric equations working backwards from ratios to angles. So again, keeping those ideas in mind here, we want to find all of the solutions in the interval such that cosecant of x is equal to -2 over root 3. All right, and with cosecant and cotangent and also secant, sometimes it's best to use your reciprocal identities. Kind of what they're also asking us here is, where is sine of x equal to -√3 over 2? And remember that these are y values. These are your y values. So if I go ahead and I draw my unit circle, sine is negative in quadrants 3 and 4. Okay, so quadrants 3 and 4. All right, and we want to go ahead and have a -√3 over 2. Okay, so we can go ahead and look at the y values, and if you have your unit circle, right, so where are my y values? Negative here and here. So that's 4 pi thirds and 5 pi thirds. Okay, so x is equal to 4 pi thirds, 5 pi thirds. All right, next, cotangent of theta. When is that equal to root 3? Well, I want you to go ahead and think about this, that this is really root 3 over 1. And if I divide both by 2, I get these values. Okay, I get root 3 over 2 and comma 1/2. Okay, which this is our x value. This is our y value, right? Because we have cosine over sine. And then also, too, with tangent and cotangent, even though it's positive, it could be a double negative. So you could have this situation where you're in quadrant 1 or you're in quadrant 3. Okay, so where is my x value? Negative root 3 over 2. And where's my y value? Negative 1/2. Okay, and we get that here at pi over 6 and here at 7 pi over 6. Okay. All right, so that is x equals pi over 6 and 7 pi over 6. Again, if you're struggling with like, man, how does he find these values? I mean, I'm using the chart, and then also too, it's good, to have like the unit circle memorized about where these values are, and then also too, again, the hand trick. I think that's really good. All right, last one. Here, part C, it says, go ahead and solve this equation. And this one is pretty straightforward. I'll add 1 to both sides. I'll divide by 2 on both sides. And then I'll take the square root of both sides. Cosine of theta is 1 over root 2. And that's root 2 over 2. And hopefully you know that root 2 over 2, like right off the bat, right, is a pi fourths angle. This is a 45-degree angle. And since it's positive and negative, that's just going to be every single angle. That's a 45-degree angle. Our reference angles: pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. All right. Okay. Whoa. Just like that. Lights go out. That didn't work. Okay. Hey, that is it for me. I'll catch you next time. Peace.